Good morning to all. Now, we are going to start the properties of Laplace transformations and what is this Laplace transformation. Already in the previous session, a small introduction is given to Laplace transformations. Now let us start. Now just look at. Now before going this set, the Laplace transformation of any function f of t, function or signal, that is equal to integral 0 to infinity f of t into e power minus st dt. Look at, it doesn't contain any imaginary number. Only Fourier transformation will get it. But Laplace transformation doesn't contain imaginary. Fourier sine transformation doesn't contain. Fourier cosine transformation doesn't contain. Okay? Now, formulas, direct formulas. Laplace transformation of 1 equal to 1 by s. This implies inverse Laplace transformation of 1 by s equal to 1. Now just look at, very easy. Laplace transformation of e power at equal to 1 by s minus a. This implies inverse Laplace transformation of 1 by s minus a is equal to e power at. Now, Laplace transformation of t power n, where n is an integer, that is equal to n factorial by s power n plus 1. Now, this implies inverse Laplace transformation of s power n plus 1 equal to 1 by n factorial into t power n, because n factorial is constant. Understanding? Now, similarly, Laplace transformation of sine at, that is equal to a by s square plus a square. This implies inverse Laplace transformation of 1 by s square plus a square equal to 1 by a sine at. Because a is constant, so we are not writing a here, keeping a to that side only. Now, Laplace transformation of cos at, that equal to s by s square plus a square. This implies inverse Laplace transformation of s by s a square, that equal to cos at. Now, Laplace transformation of hyperbolic function h at, that equal to a by s square minus a square. Sin at and cos at are plain trigonometric signals or functions. Sin h at or cos h at are hyperbolic trigonometric functions or signals. Here, very easy to remember this formula. Sin at is a by s square plus a square. Cos at is s by s square plus a square. For hyperbolic, in the denominator, instead of the same formula, instead of plus, you make it the negative signal, negative signature. It is enough. Now just look at. This is what the cos h at. Cos h at is equal to s by s square minus a square. Now just look at a by s square plus a square. A by s square minus a square. For cos at, s by s square plus a square. This is s by s square minus a square. Only negative sign is different. So for this purpose, L inverse of 1 by s square minus a square equal to 1 by a sin h at. This implies L inverse of s by s square minus a square equal to cos h at. Only these are the 7 formula in Laplace transformations. All these 7 formulas will lead the entire domain of the Laplace transformations. Very easy to remember. Students have to remember all these one. Here, along with these formula, some other formula are given. That is gamma of half value is equal to root pi. One more point. What is n factorial? N factorial value is gamma of n plus 1. This is equal to n gamma n. Students already learnt this formula in M1, M3 papers. There you learnt these concepts by using beta gamma functions. Gamma of half equal to root pi, n factorial gamma of n plus 1. That is equal to n gamma n. Understanding? So these are the formulas we are using in Laplace transformations. Now, along with these formulas, we are going to use some properties of Laplace transformations. Now, properties of Laplace transformations. Now look at Laplace transformation of any signal or function that is equal to f of s, then Laplace transformation of multiplying the signal with e of e power at, then this will become f of s minus a. Now this signal is called frequency shifting. This is called frequency shifting, very important. This property is called frequency shifting. Frequency shifting. Understanding? Now, general shifting. If L of ft equal to f of s, then Laplace transformation of a signal t minus a, that is equal to e power minus sa into f of s. This is right shifting. This is called only right shifting. Students should not confuse with the right shifting and frequency shifting. In the right shifting, just with the t, the signal is delayed by a seconds. Right shifting. Here e power minus sa will come as a coefficient with f of s. But this is frequency shifting. The given function or signal, no change in the given signal or the function, but it is multiplied by e power at. Whenever a function or a signal is multiplied by e power at, the output is f of s minus a. That is called frequency shifting. Very important. This is frequency shifting. This is right shifting. Students should not confuse with these two properties. These two are very much important. Understanding? Frequency shifting and right shifting. Understanding? Now third one, scaling. L of f of t, that is equal to f of s. This implies scaling property. L of f of a t, that is equal to, here a is multiplying, this will become, a will be dividing f of s by a. Now, and L of f of t is equal to f of s. If dividing t by a constant a, now this will become a times f of s. This is called scaling property. This is called scaling property. The scaling property is same for all transformations. Remember, we did the scaling property in case of Fourier transformations, Fourier sine transformations, and Fourier cosine transformations. Here also we are doing the same scaling properties in Laplace transformations. You see anything, nothing changed in their properties. This is same. Understanding? One more point. Again, I am telling there is a good difference between frequency shifting and right shifting. Right shifting means e power minus sa will come out. Frequency shifting means what? Multiplying with the e power at. Understanding? So these are the important properties of Laplace transformations. Now just we are going to discuss all these problems. Okay, let us start. Let us start. For example, what is Laplace transformation of sine 3t? Laplace transformation of cos h 4t, or Laplace transformation of sine 2t, and Laplace transformation of cos 2t. And what is the Laplace transformation of sin ht, for example? These are the first I have to do. Now just look at, this is of the form sin AT formula. What is Laplace transformation of sin AT formula? That is equal to a by s square plus a square. Now here, in place of a, what is the value? 3. A square, that means 9 by s square plus 9. Over, only direct application of formula, cos h 4t. What is the Laplace transformation of cos h 4t? Cos h at formula. What is the cos h formula? S by, because of hyperbolic, s square minus a square. So this is s by s square minus 4 square means 16. Similarly, for cos 2t, that is equal to s by s square plus 4. For sin ht, that is equal to a. Here a means what? 1 into t. T means 1 into t. This 1 equal to a. Therefore 1 by s square plus a square. Now just look at how these formulas are very easy. One more point. What is Laplace transformation of e power 3t? E power 3t formula is 1 by s minus a, that is s minus 3. Now, what is the Laplace transformation of e power minus 4t? This is equal to 1 by s minus a, s minus of minus 4, that equal to 1 by s plus 4. Understanding? Now, again, what is Laplace transformation of t? T means t power 1, that is equal to, t equal to 1 means what? Here this 1 equal to n, power equal to n. That equal to 1 factorial by s power 1 plus 1, that equal to 1 by s square. Understanding? Now, what is L of t square? Here n equal to 2, therefore 2 factorial by s power 2 plus 1, this is equal to 2 by s cube. Now, what is L of t cube? Here n equal to 3, that is 3 factorial by s power 3 plus 1, that equal to 3 factorial 6 by s power 4, etc., etc. Now just look at, all these are just simply applying the formula of Laplace transformations. Now all directly simply just we are applying. One more point. Look at, if f of t equal to t square. T square. What is f of t minus 2? T minus 2. Look at this one. Laplace transformation of f of t, that is equal to L of t square, that equal to 2 by s cube. This is equal to f of s. Now, in this place, what is Laplace transformation of f of t minus 2? This will become f of s minus 2. Wherever there is s, keep s minus 2 whole cube. This is right shifting. Understanding? All these are right shifting methods. Okay, in the next session we are going to start remaining problems. Thank you.